Hello everyone, I am Dr. Rajesh and I am again with you with new video lecture, and in this video lecture we will study resultant of two forces acting at a point. So we will be studying this topic. Let us suppose that P, say this force is P and this force is Q in this direction. Okay, are two forces acting at an angle alpha, and let us complete the parallelogram. So it will be exactly parallel so by parallelogram law of forces, their resultant will act along the diagonal. Okay, let us name them as, say, A, B, C, and this is D, and the direction will be in this direction by parallelogram law of forces, and say this is resultant R, this is also force Q, this is parallel, since it's parallel, this is P, this is also in this direction, and say resultant R is making an angle theta with the direction of force P. So this theta is with the direction of force P. Alpha is the angle between P and Q. Fine. So here two cases are there. Case number 1, when alpha is acute angle, in that case we will get, this is figure number 1, we will get figure 1. Secondly, case number 2, alpha is obtuse angle, means greater than 90 degree. So in that case what will be the figure? Forces will still remain the same. This will be force P. Now since angle is greater than 90, so this will be something like that. This is force Q. Now complete the parallelogram, will get okay, and this parallel to this one. This is extra, so I am going to rub it. So we are going to rub this one. So we have removed that extra portion. So I am going to name the points now. Points will be same. This is A, B, C, D. Fine. And the resultant will be the same along the diagonal of the parallelogram, and it is given by R. Again, alpha is the angle between them. This is alpha, and this is if you write, this is theta. So now we will see in both the cases. This is case number 2. In both the cases we will try to find the direction of the resultant. The direction of the resultant, direction means the angle which it is making with P, the angle this is also making with P. In both the cases we will find the direction. Direction means the angle which the resultant is making with the direction of P, and in the second case also, and the magnitude that we will also be determining. So we will be completely determining the vector, that is resultant force R, which is a vector quantity. And to determine a vector quantity completely, you need to determine the magnitude as well as the direction of the resultant, like this one and in this also. So we will doing that in the later part of the question. So now let me do some calculations. In the case number 1, can we make a right angle triangle? So if you allow me, can I produce it something like that, and can I drop a perpendicular over here? This angle is 90 degree. Okay, fine. And you will see, if this angle is alpha, so this angle will also be alpha. So if you allow me to write it over here, alpha, fine. And can I name this point as point E? So in right angle triangle BDE, this angle is 90 degree. So this is hypotenuse, this is alpha. So what will be this ratio? B upon BD. So I am going to write it over here. This is B upon BD, which is nothing but cos alpha, but BD is nothing but Q. So this will be cos alpha, because if we write BD is nothing but equal to Q, it is very much clear. If you look over here, this is Q, this both are parallel. So this is also BD is representing the force Q. So this B is equal to Q. Secondly, we will also see in the same triangle what will be ED upon BD. So shall I be writing it over here? It will be ED upon BD will be sin alpha. Okay, so you can name these equations as, this is named as equation number 1 and this is named as equation number 2. So firstly we are going through the case number 1. Now if we see, this AE is equal to AB plus B. This is very clear from the figure. So if I write from figure, AE is equal to AB plus BE. So we have the value of this one. What is the value of B? We have value Q sin alpha. So here is AB. So what will be the value of AB? AB is this force P. So I will be writing it over here. This is AB is force P and B is Q cos alpha. Okay, you may write it as here from equation it is 1. Okay, so A is this one, and you may name it as equation number 3. So you will try to find the tan theta from here. You know tan theta in the right angle triangle. If you go over here, so let me find the tan theta. Okay, so I will be finding, firstly I shall be writing in right angle triangle ADE. What is this ratio? D upon AE, nothing but tan theta. This implies that tan theta is equal to D. What is D? Can anyone tell me what is D? This is D. Do we have any value of D or ED? ED and D both in magnitude, both are same. What is this? ED upon BD we have, and BD is Q. So okay, let me just handle this one. A is we have D upon A is P plus Q cos alpha. So D upon BD, we have that value from equation number 2. So I have introduced BD over here. So here will be BD divided by P plus Q cos alpha, and from equation number 2 this thing is sin alpha. So I am going to write it over here, sin alpha. And what is BD? BD is Q. BD is Q divided by P plus Q cos alpha. So this implies that tan theta is equal to Q sin alpha P plus Q cos alpha. So this is the direction of the resultant in case number 1, and you may name it as equation number 4. Also, if we see the right angle triangle ADE, hypotenuse is this one. Okay, this is 90 degree. So what is the Pythagoras theorem? AE square plus ED square is equal to AD square. So I will be using the Pythagoras theorem. And what does Pythagoras theorem states? It simply states that I will be using this space and writing over here AE square plus ED square is equal to AD square. Okay, fine. AE from here is P plus Q alpha Q cos alpha, and what is ED? ED is BD sin alpha, and BD is Q sin alpha. So if I write it over here, ED is equal to BD sin alpha, and BD is Q sin alpha. Fine. Okay, this is fine. So I will be using these values over here. A is from here P plus Q cos alpha, P plus Q cos alpha whole square plus ED is equal to Q sin alpha whole square is equal to AD. AD is the resultant R, so it will be R square. So this implies that R square is equal to P square plus Q square cos square alpha plus 2PQ cos alpha plus Q square sin square alpha. So this will be common, P square plus Q square, and inside will cos square plus sin square alpha, this is 1 plus 2PQ cos alpha. Taking square root on both sides, R is equal to P square plus Q square 2PQ cos alpha and the whole square root. So this is the magnitude, fine, and is given by equation number, you may write as equation number 5. So thus we have determined the direction and magnitude of the resultant in case number 1 when alpha is acute angle. Now we will be studying the case number 2 when alpha is obtuse angle. So here we are, the case number 2 when alpha is obtuse angle, means greater than 90 degree. So we will be studying this case also. So let me first complete, we draw this perpendicular. So this angle will be 90 degree. Okay, this angle is 90 degree and this angle is alpha, fine. So if I produce it like that, okay, so this angle will also be alpha. So there would be no exaggeration if I write here as alpha, and we know that total angle on a line is 180 degree and this part is alpha. So this remaining part will be 180 minus alpha. So let me write it as this angle is pi minus alpha, 180 minus alpha. So if I write in right angle triangle and instead of here writing as P, I should be writing the same symbol E. So I am going to rub it and write it over here as E. I am going to write it over here as E. So here will be E, so as to make the resemblance between both the cases for acute and obtuse. There we also had taken E, so I have taken here as E. So now in right angle triangle, DEB. So this right angle triangle DEB, this is pi minus alpha, this is 90. So this is hypotenuse. So if I find two ratios, the first is ED upon hypotenuse DB is equal to, this is pi minus alpha ED and this one will be sine the angle, angle is pi minus alpha, and here this one divided by this one, EB divided by DB is equal to cos pi minus alpha is equal to sine alpha ED upon dB, and this is dB, and you know dB will also be Q. Fine. So if I write it over here, this ED is equal to Q sin alpha, and this EB upon dB is equal to minus cos alpha. So you may write these equations as up to 5 we have done. So this will be 6 and this will be 7. So likewise, as we did in the last case, we will be writing AB AE is equal to AB minus EB. Like you see over here, AE, in the earlier case we also calculated AE. So here A is AB minus this portion EB. So if I write AB is very much clear, it is P, force P. So that was force P that I have rubbed. So this is force P, this is force P. So AB is force P, and minus, if I write, you will see EB upon dB. So if I write it over here as EB upon dB into dB, this is equal to P plus minus EB upon dB, and this is dB, which is nothing plus this minus from here is cos alpha from this equation number 7. So this will be cos alpha, and dB, what is dB? dB is Q, dB is Q. So this will be P plus Q cos alpha. So A is this one. Now in right angle triangle A D E, tan theta will be equal to D upon A. This D upon A, this angle is theta. So D, we have D or ED both are equal. So likewise we can calculate, this will be Q sin alpha, and A is P plus Q cos alpha. Similarly, we can find the magnitude, which will be given by R square is P square plus Q square plus 2PQ cos alpha, and the square root. You can easily calculate, and I am leaving it up to you. So in both the cases we have determined the direction and the magnitude of the resultant. Now we will study some special cases, and the special cases are these. Number 1, when alpha is 90 degree. So for discussing the special cases, I am writing again the formula tan theta is equal to Q sin alpha divided by P plus Q cos alpha, and R is equal to P square plus Q square plus 2PQ cos alpha, where you know the general interpretation. This R is inclined with force P. This is P, this is Q, and this we have completed the parallelogram. This is R, this angle is theta, this angle is alpha. So, this will be the case when this R resultant is inclined with P, and if you opposite case here, instead of it inclining with P, it is inclined with Q, then what will be the formula for tan theta? You can also, I can also write the case for U. Let me take it as, if this would have been the case, this is Q, this is P, and let me complete the parallelogram. This angle is theta, this angle is alpha. So, what will be the formula in this case? In this case, you will write tan theta. Now, formula to remember, the theta with which it is making angle, it is making angle with Q now. So, other force is P. In this case, it was making angle with P, other force was Q. So, here is Q sin alpha plus the primary force with which it is making angle, it was P, and the other force cos alpha. So, here if I say that it will remain the same, here sin alpha will remain the same, cos alpha will remain the same. Now, I have to fill out the details. Theta is angle that it is making with Q. So, here filling the blanks, the other force will be P. So, instead of Q, I will writing here P. Q is the primary force, here Q, and here is also the other force is P, because primary force with which it is making alpha, this is primary P, the other is over both the side, it is other force Q. So, in this case it will be the formula. So, you have to keep it in mind, both the cases you should be knowing how to write tan theta. Okay, R will remain the same irrespective of the inclination of R with either of the force. So, now we will study the special cases here. So, you will see the case number 1. When alpha is pi by 2, in this case both the forces are at right angle to each other, like that. So, let me complete this one. So, this is say angle, this is theta. So, in this case we will write tan theta will be, so say this force is P, this force is Q. So, we will be using this formula, this is Q sin pi by 2 P plus Q cos pi by 2. Q sin pi by 2 is 1, Q cos pi by 2 is 0. So, this will be Q by P, implies in this case tan theta will be Q by P, and resultant will be P square plus Q square plus 2 P Q cos pi by 2. Fine. So, this will be P square plus Q square, and cos pi by 2 you know is 0. So, this is the resultant. So, this is the case number 1. Now, case number 2, we will be studying this is case number 2. when both the forces are equal, P is equal to Q. In that case, we know tan theta is equal to Q sin alpha divided by P plus Q cos alpha. Both are equal, say P, both are equal to P. So this will be sin alpha 1 plus cos alpha. So sin alpha is equal to sin alpha by 2 cos alpha by 2 2 cos square alpha by 2. 2 to 2 will cancel out, alpha to alpha will cancel out. So this will be tan alpha by 2. This implies that theta is equal to alpha by 2. So if both the forces are equal, say if this is this much force, this is also this much force, so both are unequal in magnitude, then their resultant will bisect the angle between them. So this will exactly bisect the angle between them. So this will be exactly, if this will be alpha by 2 and this will be alpha by 2, if total angle is alpha. So this is the result of this direction of the resultant. Now next, R in this case will be P square plus P square plus 2 P square cos alpha. So this will be, because we have taken P is equal to Q, so P square will be out. So this will be 2 plus 2 cos alpha. So P root 2 1 plus cos alpha root 2 P 2 cos square alpha by 2 root 2 P root 2 cos alpha by 2 2P cos alpha by 2. So this implies that resultant will be 2P cos alpha by 2 and theta will be alpha by 2. So this will be the information of the resultant in this particular case. Now case number 3, when alpha is 0, both forces are parallel to each other. So in this case we will be finding tan theta. You know the tan theta is equal to Q sin 0 P plus Q cos 0. So this will be 0 by P plus Q, which is 0. This implies that tan theta is 0. This implies that the resultant will be parallel to the forces. And what will be the magnitude? P square plus Q square plus 2PQ cos 0. Fine. And the square root, this will be P square plus Q square plus 2PQ cos 0 is 1. So this will be P plus Q whole square root is equal to, this will cancel out, P plus Q. So magnitude will be P plus Q. So if one force is in this direction, another is parallel to this one, this is force P, this is Q, so the resultant will be in the same direction at angle 0 degree, and resultant magnitude is P plus Q. So now we will study the case number 4, when the angle between the forces is 180 degree. So tan theta is equal to q sin pi p plus q cos pi is equal to q 0 p minus q is equal to 0. In this case also tan theta is equal to 0 implies theta is equal to 0 degree. Fine. And what will be the magnitude? The magnitude will be p square plus q square plus 2pq cos pi. Fine. This will be p square, cos pi is minus 1 minus 2pq square root. So p minus q whole square, this will cancel out, this will be p minus q. So resultant will be p minus q. This will be the least resultant of the two forces acting at a point, and this will be the greatest. This will be the greatest resultant of the two forces acting at a point. So in the exam, if it is asked that find the greatest and the least resultant, you have to discuss both the cases and tell them that this is the greatest, because the greatest resultant can be when both forces are parallel. In that case the magnitude will add up, and when both forces are anti-parallel, like one is the in this direction, say this is q, another is in this direction, say this is p, so resultant will be in this direction and will be of the magnitude p minus q. This will be the least. Okay, so in the examination if it is asked what is the greatest and least resultant, you will discuss both these cases. Now case number 5, when force P is greater than Q. This is case number 5. When force P is greater than Q. This implies that, now adding both sides, we know that tan theta is equal to Q sin alpha and P plus Q cos alpha, where theta is the angle resultant is making with the force P. So that is very much clear with this formula. So as here is P plus Q cos alpha, so here is P. So I will be adding Q cos alpha on both sides, so as we could make use of this thing. So I am going to add up Q cos alpha on both sides. This implies that P plus Q cos alpha divided by Q sin alpha on both sides. Q sin alpha. We are going to explore this thing. So here is Q sin alpha, so we have divided it as Q sin alpha. So what now I am going to do is going to switch, going to send this thing over here and this thing over there. So this will be Q sin alpha divided by Q plus Q cos alpha both ways, okay, greater than Q sin alpha divided by P plus Q cos alpha. Q to Q will cancel out. This from this formula we know that is equal to tan theta. So this will be sin alpha divided by 1 plus cos alpha. This will be tan theta. This implies that 2 sin alpha by 2 cos alpha by 2 2 cos square alpha by 2 greater than tan theta. 2 to 2 will cancel out, cos alpha to alpha by 2 implies tan alpha by 2 is greater than tan theta. implies alpha by 2 is greater than theta, implies theta is less than alpha by 2. Now I am going to interpret this thing. Interpretation will be P was greater, so I am going to make it as greater. This is greater, P is greater, Q is smaller than P, like this much only. So in that case I am going to complete the parallelogram. You see this result says that this angle is alpha, half of the angle will be this one, so here is alpha by 2 and here is also alpha by 2, but this angle theta in this case, because P is greater than Q, in this case this angle theta is, obviously you can see this angle theta is less than, this is alpha by 2 and this is theta, so this theta is obviously less than alpha by 2. So if I say that resultant, what will be the interpretation? Resultant in this case, when P is greater than Q, will be inclined, means झुकना, inclined more towards greater force P. So this will be inclined more toward, like this is inclined, झुकना, ये झुका हुआ है P की तरफ, so this is theta is less than alpha by 2. So whichever force is greater, resultant will be inclined more toward that particular force. This is the interpretation of this case number 5. So this is all I have from this lecture, and in this lecture we have studied and determined the resultant of the two forces acting at a point, and also studied the different cases. Those were the 5 cases, and those 5 cases were exclusive and exhaustive cases, and have covered every possible case scenario of the forces acting at the two forces acting at a point. So I hope you will be able to understand this idea, and you will thoroughly go through this, and in the later lectures I will be taking the problems based upon this article. So till then, take care, bye bye, see you soon, and this is Dr. Rajesh saying goodbye, take care, and I will be back very soon with my new video lectures. Till then, take care.